This video introduces noise contrastive estimation language model. Noise contrastive estimation method is a special case of importance sampling, which is used to efficiently train the neural probability language models. The main idea of NCE converts a density estimate to a binary classification problem that discriminates between samples from the data distribution and from a noise distribution. A density function PD is the conditional probability of the next word W over the data distribution D occurring after the context words H. The goal is to use a maximum likelihood estimate to fit a context-dependent model P theta. Here is the importance sampling distribution to the data distribution by optimizing the model parameters theta. Suppose that key samples are drawing from a knowing noise distribution Pn, while drawing one sample from the data distribution PD. We generate a mixture distribution here. The model predicts the probability of the next word W by classifying word from PD and Pn. The posterior probability that sample W comes from the data distribution D is expressed in this formulation. To fit P theta to PD, we use P theta to replace PD here by introducing this model parameters theta. A neural network is used as a classifier to classify this W sampled from the mixture distribution is from the data distribution or from a noise distribution. We define the expectation of a log posterior probability under the mixture of the data and the noise samples as the objective function, which includes two terms. First term is the expectation of this log over PD. A second term is the expectation of this log over Pn. To use the gradient descent method to train the model, the gradient of the loss function with respect to the model parameter theta is computed as follows. This gradient includes two terms. The first term is the expectation of this value over PD and the expectation of this value over Pn. Using Monte Carlo approximation, we convert this expectation to integral, and then I use this sum to approximate this integral. Then the difference of two expectations above is converted to sum of samples W over the mixture distribution. The difference between these two gradients is that when we use this gradient to train the model, we need to calculate the expectation of this value over this PD and over this Pn. However, if we use this as a gradient to train the model, we need to only sample W over the mixture distribution until reach the convergence. From this formulation, we can see when k tends to infinity, we have this formulation for the gradient, which is the maximum likelihood gradient. For more details, please check with this reference. Thank you. Bye.